Welcome, ladies and gentlemen. Today, for this third video, we're looking at option 2, working with zeros in order to decompose a fraction. This is our second option and the one that I generally prefer. Now, we're going to start off in the same way we did before by factoring our denominator into x plus 2, x minus 4. We're going to set up two fractions, one for each of our factors, and we put them plus in between. The first factor goes in the denominator of the first fraction. The second factor goes into the denominator of the second fraction. And because I have a linear term in the denominator, I must have 1 degree less, and therefore a constant in the numerator. I'm going to use a and b again. We're also going to follow the same process of multiplying the second denominator by the first equation in order to get the common denominator. And then we're going to multiply the first denominator by the second equation to get the common denominator. And when we have the common denominator, we are only working with our numerator. So negative 2x minus 10 is equal to a times x minus 4 plus b times x plus 2. Now, the zeros that we have are x equals 4 and x equals negative 2. And we're going to plug each of these in for the entire x's that are given, and we will then be able to find our a and b. So let's start with the x equals 4. This is giving me negative 8 minus 10 equals 0a plus 6b. And I end up with negative 18 equals 6b. Dividing both sides by 6, I get negative 3 equals b. Plugging in negative 2 will give me negative 4, positive 4 minus 10 equals negative 6a plus 0b. And therefore I have negative 6 equals negative 6a for 1 equaling a. Putting them back into my original fraction, I have 1 over x plus 2, and then I'm going to put the negative in between with the 3 over x minus 4. And if you recall, this was our original sum difference that we had at the beginning. Notice that this was a much easier process. This is the case when we have two factors that are consistently different. But as we end up moving through, things get more difficult. In the next video, we'll talk about what happens when we have higher degree polynomials or common factors. Thank you.